Students, how you doing? I haven't made a video in so long, I'm kind of nervous. My name is Mr. Elliott and I'll be your math teacher today. We're getting to the last two chapters, and our last two chapters are all about trigonometry. And before we can really properly introduce trigonometry, we have to talk about some triangles, because trigonometry comes from triangles. And the first thing we usually like to do is talk about special right triangles. This is all stuff that we've done before in geometry. So hopefully this is a review for you. This is the breakdown of the 45, 45, 90 triangle. If this is the 45 and this is the 45, this is the 90. The two legs are both going to be congruent because it's an isosceles triangle, and the hypotenuse would be to a value of whatever the length of the legs are times square root 2. Or if you think about it in the other direction, if you have the hypotenuse, you divide by root 2, and that will give you the length of the legs. Why? We'll talk about that on Monday. So instead of doing example number 1 first, I'm going to do example 2 first. Check it out. They say 45, 45 right angle, so that tells me immediately that it's a 45, 45, 90 triangle, and this picture pops into my head. Boop! Now that it's there, I look and I see, well, what did they give me? Did they give me the x, or did they give me the x root 2? And in this case, we're talking about the legs, so they gave me the x. So if they gave me the x, that means that the other leg will also be a distance of 3 miles. And then according to this, if I multiply this by root 2, I'll get the hypotenuse. So the hypotenuse is 3 root 2 miles. Thinking about this algebraically, the x was equal to 3, or 3 miles. And then if you want to get algebraically from x to x root 2, you would multiply both sides of the equation by root 2. So this becomes 3 times square root 2. Algebra at its best. Let's take a look at example 1, which is really example 2, I guess. Whoa, Friday. Now, they don't say 45, 45, 90, but they do say that these two sides are congruent, which makes it an isosceles triangle. This is a 90-degree angle, which means it's an isosceles right triangle, which means that these two angles must be congruent. And if these two angles must add up to 90 degrees, so that all three angles add up to 90 or 180 degrees, that means that both of these angles must be 45 degrees. We have a 45, 45, 90 triangle. This picture pops into my head. Boop! And you look to see what you have. You have the hypotenuse, which is the x root 2. So if I think about this from an algebraic standpoint, keep the camera on, Elliot. If I think about this from an algebraic standpoint, this is the x root 2. So I set 10 equal to x root 2. And I need to algebraically solve for x, so I divide both sides by root 2. And I end up getting x equals 10 over root 2. And as we have learned previously, you cannot have a root in your denominator, so you multiply this by root 2 over root 2, and you get 10 root 2 over 2. 10 divided by 2 is 5, so you end up getting 5 root 2. So this side, which is x, is 5 root 2 centimeters, and because these two sides are congruent, this side is also 5 root 2 centimeters. Because we are dividing by square roots, that reminds me, for this chapter, you will not be able to use any of those scientific calculators that I've been banning throughout the year, because those simplify roots for you. Okay, so those are the 45, 45, 90 triangles. Any questions? So once you're good with the 45, 45, 90 triangles, then you would work into the next level up, which is 30, 60, 90 triangles. In a 30, 60, 90 triangle, the side opposite the 30 degrees will always be the smallest side. Smallest angle creates the smallest side. So because that's the smallest side, we call it x. The side opposite the 60 degrees would be x root 3. And the side opposite the 90 degrees will be 2x. If you're curious why these proportions are like this, we're going to talk about that in class on Monday. All right, let's get into 3 examples. Example 1, they've turned the triangle around to try to trick me, but I see the 90 degrees here, I see 30 degrees here, so using the idea of 30, 60, 90, I know that this must be 60 degrees. They've given me the side opposite the 30, which is the dream scenario, that they give you the smallest side, which is the x side. That means that the hypotenuse is going to be 2 times that x side, and because that x side is 8, this side would have to be 16 inches. And then the side opposite the 60 degrees is the x root 3 side, so because x is equal to 8, this would be 8 root 3 inches. You're thinking about this using algebra. They gave me the 8 inches, which is the 30 degrees, which is the x. So x is equal to 8. Well, then to get to the hypotenuse, you multiply by 2. So if I multiply both sides of this equation by 8, I get 2 times x equals 2 times 8, which is 16. So that's where that comes from. Or if I wanted to get the x root 3 side, I multiply both sides of the equation by root 3. So x root 3 is 8 root 3. Multiplying both sides by root 3. So that's algebraically how we're getting the 16 and the 8 root 3. Some people like to do this algebra. Some people like to do the math in their heads. I'm actually okay if you do the math in your heads on these ones. Example number 2. In this one, I have 60 degrees here and a right angle mark, so I have 150 degrees so far. Oh, so it's a 30, 60, 90 triangle. And this particular time, they're giving me the hypotenuse, which is the 2x side. So I know that 2x must be equal to 4. Well, if 2x is equal to 4, that means x is equal to 2, which gives me the side opposite the 30 degrees. That one's going to be 2 feet. And then to get to the side opposite the 60, that's like you're multiplying by root 3. So if I took this equation and multiplied both sides by root 3, x root 3 is equal to 2 root 3. So this side right here is 2 root 3 feet. And those are my answers to this question. Okay, the last one I have for you is, what if they give you a side opposite the 60 degree one? This is the hardest type of problem that you will encounter on these ones, which is why it's my last example. But it's the side opposite the 60 is the x root 3 side. So I'm going to take this 12 and set it equal to x root 3. So if I divide this equation, I divide both sides by root 3, and x ends up equaling 12 divided by root 3. Well, let's go on the side and do some side work. How do we simplify 12 over root 3? 12 over root 3. Well, we can't have a root in the denominator, so we multiply by root 3 over root 3, which becomes 12 root 3 over root 3 times root 3, which is just 3. And then 12 divided by 3 is 4, so 4 root 3. So x root 3 equals 12. When I divide both sides by root 3, that ends up being 4 root 3. And that gave me the side opposite the 30 degrees. So the side opposite the 30 degrees is 4 root 3 yards. And then last one, if the side opposite the 30, if the x is 4 root 3, the side opposite the 90 is going to be when you do 2x. So I'm going to multiply both sides of this equation by 2. or excuse me, by 2. So 2x equals 2 times 4 root 3. And as everybody knows, 2 times 4 root 3, 8 root 3. So the hypotenuse ends up being 8 root 3 yards. Okay, that's the ins and outs of 30, 60, 90 triangles and 45, 45, 90 triangles. When I was looking through your homework tonight, specifically this problem number 3 here, I thought these problems were a little bit confusing. So I thought I would show you 3 scenarios, and in every single one of these scenarios, the answer is always yes on the worksheet. I don't know if the answers are actually yes or no. I guess we'll figure that out on when you're doing the homework and you're checking your answers. But in these scenarios, the answers will always be yes. And if you don't get these scenarios to work out, then your answer would be no. First of all, so they have they're giving me the 2 legs. Now the one thing I don't know is which one's supposed to be the 30-degree leg and which one's supposed to be the 60-degree leg. Well, the 60-degree leg will be the bigger number, so I think the bigger number is 18. And if you just want to verify that, 6 root 3, I got 10.39, so definitely shorter. So the 6 root 3 would be opposite the 30, and the 18 would be opposite the 60. And we're curious, is this based in reality? Well, let's figure it out. Side opposite the 30, the 6 root 3, that's the x. So if x is equal, start over, if x is equal to 6 root 3, and I want to get the 60-degree side, that is the x root 3 side. So if I went x root 3, I have 6 root 3 times root 3, which becomes 6 times 3, which becomes 18, which verifies that this is a 30, 60, 90 triangle. So I answer yes. Second scenario. Okay, they give me the hypotenuse, they give me the leg. Now the one thing they're not telling me is which scenario is this? Is this that this hypotenuse is 10 and the side opposite the 30 is 5? Or is it that the side opposite the 60 is 5? I kind of need to run it through both scenarios, and if either scenario is a yes, then the answer is yes. And that's what you're going to get from right here. The side opposite the 30 is the 5, so x is equal to 5, and we're looking for the hypotenuse. If I do 2x, I get 2 times 5, which is equal to 10. So I did get a scenario where this leg and this hypotenuse, it works out that it is a 30-60 triangle, 30-60-90 triangle. So in this one, the answer is yes. If I would have tested this one out, it wouldn't have worked out. I have the side opposite the 60, so I have 5 equals x root 3. Divide both sides by root 3, so I have 5 over root 3 equals x, which when you multiply this by root 3 over root 3, you get x equals 5 root 3 over 3. And then when you multiply both sides by 2, you get 2x equals 10 root 3 over 3. Either way, is this equal to 10? No. So this one was a no. But because this one was a yes, the answer is yes. You are a 30, 60, 90 triangle. Or at least you can be. Last one. They give me a hypotenuse. They give me a leg. And like I said earlier, the answer to this is yes. I just want you to I want to make sure that you see scenarios that the answer is yes. It could be like this, that the hypotenuse is 12 and this leg is 6 root 3. Is this a feasible scenario? Or is it this one where this is 30, this is 60, and this leg is 6 root 3, and this is 12? Well, if I work out this one first, because it's on the left, if x is, it's opposite the 60, so if x is equal to 6 root 3, this is the 2x, If I multiply both sides by 2, I get the 2x side equals 12 root 3. Well, that's not equal to 12, so this is not a 30, 60, 90 triangle. If I look at this one, though, the side opposite the 60 is 6 root 3, and that's the x root 3 side, so x root 3 equals 6 root 3. And if you divide both sides by root 3, oh, that's nice. The root 3's just straight cancel out, so you get x equals 6. Then, if you need to get to the hypotenuse, which is the 2x side. So if you multiply both sides by 2, 2 times 6 is 12. I did get the hypotenuse. So the answer is yes. So this is, or this can be, a 30, 60, 90 triangle. If I would have tried out this scenario and the answer was no, and if I would have tried out this scenario and the answer was no, then the entire answer would have been no. But these are the two ways that the answer could be yes. Yeah, and then when it gives you the 2 legs, you just have to make sure that the smaller leg is the 30 and the longer leg is the 60 side. Well, that's all I have for you, everybody. I hope you've had yourselves a beautiful weekend, even though I heard it's going to rain. And we'll talk about special right triangles on Monday, and we'll jump into SOHCAHTOA on Tuesday. Anyway, I love trig. I'll talk to you later. Bye-bye.